Hey everyone, this is 8.6. It is the last lecture for unit 2, and we are talking about systems of nonlinear equations. So 8.1 was two equations at once and where they intersected each other, right? But those were only linear equations. These are nonlinear, okay? It's nonlinear because of this power. This is not 1. So we know that it's quadratic. It's not going to be a straight line. There were 3 options for finding the solution of linear equations and where they intersected, right? There was they intersect in one place, you get one solution. They do not intersect, they are parallel, there's no solution. Or the 2 lines are on top of each other, which means infinite solutions, okay? If they are not both linear equations, it would be like one line and one circle. Then the risk is, right, that there is more than one solution. So if they're just linear, there can only be one solution, infinite solutions, or 0 solutions. There can't be 2, right? Because it's just 2 straight lines. They can only cross once. But if one of them curves, or if both of them curve, you might get more than one answer. So that's the difference. You have to like look a little bit more closely at the terms because they don't have, it's not as easy to spot like terms. You see how the 2x and then this is 2x squared. Those are not actually like terms. Those are just different. Yeah, so we still use the elimination method and we're just going to find out where the graphs might cross. Okay, so this equation, the first one is linear because there is only an exponent of 1 on the variables x and y, right? There's no 2, there's no 3, there's no 4. But the second one has an exponent of 2, which means the graph will curve in some way. Okay, it's a quadratic equation of some kind. If you look at this and you line it up, it lines up a bit differently. So this one would be 2x minus y equals -4. But here 2x squared, we wouldn't put right below 2x because it's a different term. 2x squared minus y equals 0. So when I'm lining it up, they line up differently. There is only one like term. No, sorry, there are 2. So the like terms are y and then the constant, right? You can cancel out constants, but I don't think it will help you. The 2x and the 2x squared are not like terms. So if I'm interested in eliminating something, one of the variables, the x or the y is really the only variable I can eliminate. So what I'm going to do is I'm just going to multiply the top line, or sorry, the top equation. We have to stop calling them lines because they're nonlinear. I'm going to multiply the top equation by -1. In that case, I will get a plus y and I can cancel out with a -y, okay? So that will be times -1 and then -4 will be times -1, okay? So I'll rewrite all of this. Now I have -2x plus y equals +4. And down here I have nothing changed. 2x squared minus y equals 0. These 2 cancel. 2x squared minus 2x equals 4 plus 0 is just 4. Okay. Now we have a quadratic equation, and instead of solving, since we still have 2 variables, instead of solving for x, we need to solve for a quadratic, which means our choices were what's it called? Factoring. Or using the quadratic formula. Whichever one you like. Well, I mean, some of them don't factor, so in that case, use the quadratic formula. So the first step is that for either of these is we have to set it equal to 0. Right now, this equation is a quadratic equation, but it is set equal to 4. So what that means is I need to move 4 over. So I'll subtract 4, subtract 4. 2x squared minus 2x minus 4 equals 0. Okay. Is this factorable? It looks like it might be factorable, right? So it's still set equal to 0. 2x squared will become a 2x and an x, right? 2x times x gives you 2x squared. For -4, our options are -4, 1, +4, -1, and 1 -2, and 1 +2. Which one of those do you think would give you a -2? Because remember, we're going to multiply one of them by 2. So I think if we multiply the 2x by -2 and the regular x by +2, you'll get a -2x. And we can just check it real quick. 2x times x is 2x squared. 2x times -2 is -4x. 2 times x is +2x. And +2 times -2 is -4, which does match up there because that would become 2x squared minus 2x minus 4. So that's okay. You can factor it, or we could do the quadratic equation, right? The quadratic equation says that A is 2, B is -2, and C is -4, right? AX squared minus BX minus C. Sorry, AX squared plus BX plus C. So A is 2, B is -2, C is -4. And then our quadratic equation is -b plus or minus the square root of b squared minus 4 times A times C over 2A. So substitute those in if you want. Minus a -2 plus or minus the square root of 2 squared minus 4. Sorry, -2 squared minus 4 times 2 times -4 over 2 times 2. So that becomes, oh, sorry, this is all supposed to be x equals, right? That becomes 2 plus or minus the square root of 4 plus 32. -4 times -4 is a +16. +16 times 2 is 32. And on the bottom we have 4. So that will become, and I'll just move that up here. So 4 plus 32 becomes 36. X equals 2 plus or minus the square root of 36 over 4. X equals 2 plus or minus the square root of 36 is 6, because 6 times 6 is 36 over 4. So that gives us two different answers, right? 2 plus 6 over 4 and 2 minus 6 over 4. 2 plus 6 over 4 is 8 over 4. When you divide 8 by 4, you get 2. 2 minus 6 over 4 is negative 4 over 4. You get negative 1, right? Okay, so for our quadratic equation, if I use the quadratic formula, I got 2 and then an x, y, or I got a negative 1 and whatever my y is, okay? Factoring, I jumped ahead, I didn't finish factoring. So this is what we need to factor. 2x plus 2, x minus 2 equals 0. Now we're going to solve each of these. We're going to set each of these equal to 0 and solve them and see what we get for x, okay? 2x plus 2 equals 0. So here I will subtract 2. 2x equals negative 2. Divide by 2. X is negative 1. And then over here I have x minus 2 equals 0. I'll add 2 to both sides. X is 2. So sorry, I did not finish that very clearly. I just jumped right into the other method for finding x. But in both cases, we found the same answer for x. X is negative 1. X is 2, right? So it does not matter if you choose factoring or the quadratic formula, you will get the same x value. Now with this x value, what you need to do is find y. You can use either of your systems. I'm going to use the system without the exponent 2 because I think it's easier, okay? So that equation is 2x minus y equals negative 4. And I'll use this 2 first. So that means it's 2 times 2 minus y equals negative 4. So that's a positive 4 minus y equals negative 4. Let's subtract the 4 so that I get negative y equals negative 8 and divide by negative 1. If I divide both sides by negative 1, that means I changed both the signs. So y is 8 when x is 2. All right. And then I'm just going to do that exact same thing. But instead of x is 2, now x is negative 1. So now I have 2 times negative 1 minus y equals negative 4. Negative 2 minus y equals negative 4. Add 2. Negative y equals negative 2. Again, divide by negative 1. Changing both the signs. So y is 2 when x is negative 1. Okay. Y is 2 when x is negative 1. Y is 8 when x is 2. So these are the two solutions. These are the two solutions to this system. Because this is a curved line, it can cross the this is a curved graph. It can cross the linear graph in two places. Those two places are 2, 8 and negative 1, 2. So if I check on Desmos, I should be able to graph those two equations and then see that they cross each other at x2, y8 and x negative 1, y2. All right, so we're going to check in Desmos that these two equations cross each other at these 2 points. Let's find out. I already put it in. All right, so our first equation was 2x minus y equals -4. And our second equation was 2x squared minus y equals 0. And the points where they cross are 2, 8, which was one of our points, and then -1, 2, which was our other point. So that means it fits. That means our solutions are correct. Those are the only two solutions, and we found them both. Here, another example. Solve the following system. X squared plus y squared equals 4 and y squared minus x equals 4. So neither of these are straight, right? The only like terms we have again are the y squared and the constant, but you can't do anything if you eliminate the constant, right? We just want to eliminate one of the variables. So let's line it up a little bit better. X squared plus y squared equals 4. That will not help me line it up. All right. X squared plus y squared. And then I'm going to leave space and put the 4 here so that I can put the x here. It's not on top of anything because it's not a like term with anything. Okay. So our like terms are y squared. I need to multiply one of these by a -1, right? In order to cancel them. So I'm just going to multiply the bottom one by -1 and rewrite this. X squared plus y squared equals 4. -y squared plus x equals -4. Okay. Now what is left is x squared plus x equals 0. That's nice. So for this factoring, right, I can just factor out an x because they both have x as a common factor. So if I take x out of both of those, right, I will have x times x is x squared and x times 1 is x. So x times x is x squared, x times 1 is x. So those are my two groups. I factored it into two groups. Now we just say x is set equal to 0, and then x plus 1 is set equal to 0. So obviously that means x is 0. This one will subtract the 1. X is -1. So for this system, we have x is 0 and x is -1. I'm going to put them over here because we still need to find our y. 0, comma, y. -1, comma, y. Okay. To find the y values, we just put 0 into either of these. I'll use the one with only one exponent 2. Okay. So y squared minus x equals 4. X is 0. So now it's y squared minus 0 equals 4. Y squared equals 4. And what we do now is we square root them both and don't forget the plus and minus. So that becomes y equals plus or minus the square root of 4. We know that the square root of 4 is 2. So that means y has two answers. Y is 2 and y is -2. So actually, for 0, we have to add a whole nother point. When x is 0, y is 2. And when x is 0, y will cross at -2. And we will graph this in Desmos so you can see what that means. But basically there are two y-intercepts for this system. Well, we shouldn't even say that. There are two places it crosses. making things up. All right, let's just keep going. Now I'm going to switch from 0 to -1. Same equation, y squared minus x equals 4. Y squared minus -1 equals 4. So y squared plus 1 equals 4. Subtract that 1. Y squared equals 3. Okay, same thing. We're going to do that square root to get rid of the square with a positive or a negative. So y is positive square root of 3 and negative square root of 3. When x is -1, y is negative square root of 3 and y is square root of 3. So let's see if when we graph these, they cross at these 4 points. X squared plus y squared equals 4 is a circle. And then y squared minus x equals 4. All right. -1, 1.732. Let's see if Desmos can do a point using a square root symbol. Where's my key? Yeah, square root 3. Yeah, there you go. And then what was the other one? -1, negative square root 3, and label it. Right? Where's that one? Down there. Very good. And then our other points were 0, -2, with a label, and then 0, +2 with a label. So those are our 4 with a label. So those were our 4 answers, and it looks like those are also where they cross. So those are correct. All right. Last example. The first thing we want to do is line up these two equations, right? Y squared minus x squared equals 4. And x equals y squared. So first of all, we need to move that y squared over so that they're on the same side. So that becomes x minus y squared equals 0, right? Because we're going to subtract y squared from both sides. And the top one is y squared minus x squared equals 4. So I should put my equals 0 way over here. So those line up. But it's already a positive and a negative. So now I can just x minus x squared equals 4. I'm going to move that 4 over by subtracting 4 from both sides. And I'm going to move the x squared in front. So it's negative x squared plus x minus 4 equals 0. Is that okay? So I just move that in front. And then I move the x behind it and put a plus because it's a positive x. And the negative 4 is at the end. negative x squared plus x minus 4 equals 0. All right, so you could try to factor it. I don't know what. I don't think it's factorable. So I'm just going to go on to the quadratic formula. So for the quadratic formula, I'll come down here, negative x squared plus x minus 4 equals 0. And if you had wanted to move everything over here and change the sign, you would also say 0 equals positive x squared minus x plus 4, okay? Those are the same equation. It doesn't matter if you move everything to the left or everything to the right, okay? But I did the orange one, so I'll just stick with the orange one. In that case, A is -1, B is +1, and C is -4. And then our quadratic formula is x equals negative b plus or minus the square root b squared minus 4 times a times c over 2a. All right, so -1 plus or minus the square root of, negative b, negative 1. Negative 1 plus or minus the square root of -1 squared minus 4 times -1 times -4 over 2 times -1. So that becomes negative times a negative is just a +1 plus or minus the square root of 1. So we have -4, -1, -4. Just so I don't make any mistakes. -4 times -1 times -4. No plus. Oh, I erased it all. -4 times -1 times -4. -16. 1 minus 16 all over -2. You see where this is going. So now we have x equals 1 plus or minus the square root of -15 over -2. So now we have a negative under the radical. A negative under a radical. And remember in 1-3, we were able to solve these using imaginary numbers, but because these are points on a graph, imaginary numbers and complex numbers are not on, you can't plot them on a graph. And so we have to go back to, this will not appear on the graph. The imaginary numbers will not appear on the graph, so there is no solution. You can stop now. And so if we graph these, they should never touch. Let's find out. Sorry. We have y squared minus x squared equals 4, and x equals y squared. They will never touch. Okay. That was 8.6, and we are required to cover 8.6. It's very similar to 8.1, but quite a bit more challenging. So it's not on the exam, it's just a homework assignment. But if you do have questions, please email me. Thanks.